Hi, we are the team number 6 and we're gonna talk about the cool or city. Heat islands are areas with urban environment that experience significantly higher temperature compared to the rural areas. This phenomenon is mainly caused by the human activities such as the construction of buildings, roads, and infrastructure that absorb and retain heat. The lack of vegetation and also green space contributes to the heat island effects by reducing the cooling effects. Heat islands can have negative impacts on the environment, health, and energy consumption, making them a major concern.
Problem description. The problem we are solving with this program is heat islands. Heat islands are urban areas that experience higher temperatures than surrounding rural areas. It is due to less vegetation and abundance of heat-absorbing materials, like the concrete. This can cause health problems, higher energy use, and also worse air quality. Now, let's talk about the Sustainable Development Goals that are related to this program. Firstly, we have the number 11, Sustainable Cities and Communities. This goal directly addresses creating inclusive, safe, resilient, and sustainable cities. Then we have the number 13, Climate Action. By reducing heat islands, you'll be contributing to global climate action. Then we have the number 3, Good health and well-being. Heat stroke and other heat-related illnesses are a major concern in cities with heat islands. Then we have the number 7, affordable and clean energy. Reducing air conditioning due to cooler urban environments can help to this goal. And finally, we have the number 15, life on land. For mitigating heat islands, support healthy ecosystems with our program.
Proposal details. Our proposal are SUTs, or also known as solar updraft towers, that have the purpose of collecting solar energy to transform it into carbon-free energy. They work by producing buoyancy to make air rise, then this air goes to turbines connected on top of the towers that can move by the air, forming kinetic energy. And lastly, the air that the tower does not use gets dissipated into the atmosphere. Heat islands and SUTs seem to be a perfect match because all the heat produced by activity on urban areas will be later used to produce clean energy by the SUTs. The production of clean energy is also essential to stop heat islands, and additionally, the hot air that the SUTs absorb will be dissipated into the atmosphere without concentrating into the urban areas. However, a single SUT could not cool an entire urban area, just its surroundings, so there had to be plenty of SUTs to stop heat islands in an entire region. But you could strategically use them to transform airflow. This alternative is not an immediate solution because it wouldn't be better than other alternatives as green roofs, but because of its capacity to produce clean energy while also reducing heat, it is our best long-term solution, and the best one overall if we take into account sustainability.
In urban areas, promote green roofs and living walls throughout workshops and subsites, education and awareness campaigns. Conduct workshops and public awareness campaigns on the importance of green space and sustainable urban design. Integrate heat island education into school curriculums and involve students in greening activities. Greening infrastructure and energy efficiency initiatives. Implement cool pavement technologies and install shade structures in public spaces. Offer incentives for energy efficient building and appliances, and provide free home energy audits to reduce cooling costs.
In these images, we can see the damage that this problem is causing in the world. Here is a graph showing an example of urban heat islands and UHIRIP in the urban and the urban and non-urban interface for part of the 6 city area. Here we can see another image that represents more or less how cities with this problem look like. An example with New York from a satellite image where temperature and vegetation are compared. Where vegetation is first, temperature is gone. And the last image provided by NASA is also a satellite image. The following images are about the implementation of our proposal and our social program, which will be solar off-drop towers, community programs, education on the subject, and infrastructure. We can see two images of the solar off-drop towers, what are its parts and how they work. In other words, the inside, and we also see another one of how it looks on the outside. The other images represent what the future could look like if we eradicate or greatly diminish this problem.
Results: the continuous movement of air within the tower creates a ventilation effect drawing cooler air from surrounding areas into the structure. This circulation helps to cool down the urban environment. Increased air circulation and reduced surface temperature will lead to a cooler urban environment, and aids air movement might help disperse pollutants trapped within the urban heat island, leading to cleaner air. Cooler buildings will require less energy for air conditioning, leading to lower energy consumption and associated greenhouse gas emissions.
Here are the conclusion of our entire team.